Hello, we are going to be talking about Chapter 7, and at the start of this chapter, we want to talk about Section 1, Classes of Dienes. So you've got different classes of dienes here, depending on the structure. You've got something called cumulated. If you look at this model that I'm holding up here in front of the camera, you can see how there's two pi bonds, and they're both emanating from this central carbon atom. This is called allene, and it's not a planar system, interestingly enough. These two hydrogens are in and out of the plane, and the rest of the molecule is in the plane. And so you've got this pi bond going to the left, to your right, and then you've got this pi bond here going this way. Okay, so this is called a cumulated diene. Technically, it's two alkenes, but we're not going to talk about this much in organic chemistry. That you experience in sophomore organic chemistry. Now, what we talk about a lot are conjugated dienes. Conjugated dienes are when the two dienes are right next to each other, okay? So this is an sp2 hybridized carbon, this is an sp2 hybridized carbon, this is an sp2, and this is an sp2. So all four of those are adjacent to one another. And that right there is a conjugated diene, okay? So there's an alkene here, and there's an alkene here, and they're right next to each other. Okay, an isolated diene is one in which the two alkenes are far removed from each other, so there's no resonance, there's no resonance stabilization of carbocations or things like that. So let's take a look at this problem here so we can understand what we need to be able to do. So this is problem 17.1 in Klein's Organic Chemistry 2nd edition textbook. For each of the following compounds, identify whether each C double bond C pi system is cumulated, conjugated, or isolated. So we want to isolate, we want to identify, maybe I'll use a green highlighter here. We want to identify the carbon-carbon bonds here, okay? So this is a carbon-carbon bond, okay? And there are no other carbon-carbon bonds in this molecule, so I think it's kind of written or posed in a bad way. But next door is a carbon-oxygen pi bond. Okay, so here's a pi bond that's adjacent to that, and here's a pi bond that's adjacent to that. Okay, so those three are conjugated to one another. So I'm going to label this as a conjugated pi system. Okay. Now that other pi system, more distant, is not conjugated with those green highlighted pi bonds, so it's isolated. So it's kind of a mixture of both. Now in this molecule here, let's highlight what we have. We have two carbon-carbon pi bonds that are adjacent to one another, and this is conjugated. So we're going to label this as conjugated as well. Okay. Now, I know that pi bond on the very left of the molecule is not in conjugation with the other two, but it's not going to make the whole molecule isolated, okay? So we're still going to label this molecule as conjugated. All right. Now, here, once again, the problem is very poorly worded, but we're analyzing just the carbon-carbon pi system, okay? So here's a carbon-carbon pi bond, and here's a carbon-carbon pi bond. And you can see how it is insulated or isolated by an sp3 hybridized carbon atom. That is to say, that carbon has no p orbitals, so we call this an isolated system. So that's how you're going to recognize if two alkenes are isolated, if there's going to be an sp3 hybridized atom in between. Okay. Next we have our carbone. So let's identify the carbon-carbon pi bonds. So we've got one here on the left, and we've got one here on the right. So those two carbon-carbon pi bonds are isolated with respect to one another. Okay. So problems B, C, and D, there are indeed two different carbon-carbon pi bonds that we can analyze very easily. in problem A, there's only one carbon-carbon pi bond, so I'm not sure what answer the textbook is really looking for here, okay? So that's the basics of part one. I hope you have a feeling now for what we're going to talk about. We're going to be talking about conjugated dienes in great detail now.